I'm really thrilled to have the distinct honor of having the last word and bring this conference to a close. And what better way to do that than to talk about the transformation that the network infrastructure needs to go through to facilitate the new digital lifestyle that everybody talked about over the last couple of days. Over the last few months, I'm sure most of you have heard the terms SDN and network function virtualization probably a lot more than you could care for. And not because they are meaningless, but because, and this is from my personal experience, because you don't quite know what the other person really means when they use those terms, because everybody has their own interpretation of those terms. What I would like to do today is bring and share the perspective of a building block supplier like Intel on that topic. Now, we heard many distinguished speakers over the last 2 days talk about how the data traffic is exploding and the need for multiple orders of magnitude of throughput that we need to supply while reducing the latency and energy requirements. And what kind of topologies the networks will need to take on to actually deliver on this promise of the future connected world. I will not go into those details because there are a lot more experts in the audience than the person on the stage. However, I would like to focus more at the building block level, or what I would call the foundational level. And as I try to do that, I will try to draw some parallels from the compute side of the world and how the cloud technologies evolved there, and see if we can learn from some of those as we try to look at this whole network function virtualization paradigm. So basically, I'll talk about evolution of the compute cloud briefly, highlight the challenges for the network function virtualization, and then talk about this term that I like to use, which is a software-defined infrastructure, rather than software-defined network, which has a very kind of limited connotation in many circles. And I think Laurie was kind of alluding to the same kind of term. And I would like to talk about that as the ideal end state we could work towards. And then really highlight some of the things we, as an industry, need to work together on to really pave the way towards that ideal end state of SDI. So let's talk about the compute cloud and how it evolved. But even before I get to that, I would like to talk about the end user perspective. And the end user that we have in mind, and I should have qualified that it was mentioned in the introduction, but sometimes when people think of Intel, most of the people think of the boxes like this or the mobile handhelds that we are getting into. I come from part of Intel that focuses on the communications and storage infrastructure side of things. So we always deal with things that are more invisible to the world, as most of the people in the audience are. But that's the kind of focus we have over the last 15 years or so. So please separate that identity from the big Intel corporation that you typically hear about. The end user that I have in mind is not the end user that uses this. The end user that we focus on are the CIOs of either an enterprise or a cloud service provider or a telecommunications service provider. And if you look at the needs of these users, you can strip off all the different exotic platform features and requirements that people love to talk about. They have three needs. And they are essentially, I must maintain my business integrity, which means that if I am an enterprise CIO, I must protect the IP of my corporation. If I need to implement some exotic firewalls or security appliances to do that, I have to do that. If I'm a cloud service provider and I provide a cloud storage service, availability and protection of that data is the primary value. It is the fundamental value I deliver to my customers, so that has to be maintained. Similarly for telcos, all the service level agreements that I have in terms of quality of service, real-timeness, etc., those have to be met. So business integrity is something paramount. However, as has been talked about several times here, lowering the total cost of ownership is a hard reality. Costs and the budgets for the CIOs are not going up. So they have to do all this while lowering the TCO. However, over the last few years, a third element has been added, which is this notion of on-demand services, which really, from my perspective, is really the element that defines the pace of innovation. Our end user that I'm talking about is being asked to provision some of these newer applications as well as the underlying infrastructure to support these new usage models at a much faster pace while still operating within these constraints, so that either their corporation is more competitive, but at the same time, more and more for some of the network infrastructure suppliers, their idea of doing it in a way so that they can actually get paid for supplying some of these newer innovations to their customers, because people are more prone to paying more for these innovative usage models at the front end of the pipeline. Usually once things get commoditized, nobody wants to pay for it. But while new usages are there and people are excited about trying new things, they are a lot more open to paying for it. So people who are asked to provide for these on-demand services, they want to do it in a way so that they can actually get paid for some of this. So these are the fundamental value propositions that these end users are driven by. So let's look at how this problem was addressed on the compute side of the world. What happened in many big enterprises, and that's how this whole trend started, as they were trying to look at solving their problem of lowering the TCO, they started standardizing and, even more importantly, instrumenting the platforms. This is one of the key things I'll come back to, that you have standard architecture that has been instrumented so that you know what the resources of a particular platform that are available for use at any given point in time. Then the second thing that happened was virtualization technology became more pervasive. And they added this layer of virtualization on top of these standard platforms. And on top of that, they added the automation framework that allowed them now to deploy these virtualized resources in a more flexible fashion on top of this standardized infrastructure that they had created. Now, what I'm showing in the picture on top is kind of some interesting topologies that some of the enterprises came up with in terms of having a hub that is more modular and scalable, but at the same time having some edge kind of platforms that would be required to meet more of the interactive and latency sensitive applications. And as they created this type of infrastructure, in my view, that was the beginning of the cloud paradigm. Because now people started adding new types of services, the software as a service, platform as a service, infrastructure as a service. They all took advantage of these fundamental, foundational things that had been created for the compute side. And these are the compute services I'm talking about. Now, as the SaaS and PaaS and IaaS kind of paradigms matured, virtualization addressed the needs of what I would call the compute resource part of it, where you had multi-tenant computing resources that were all operating on that same underlying infrastructure. The problem that these folks ran into was the network, the underlying network. Because as you started deploying disparate types of services on this common infrastructure, what you really needed was same physical underlay network to deliver different attributes of these virtual overlay networks. Because each one of these services had different demands on the network that was underneath all these things. So then people wanted a virtual overlay network that is type 1, type 2, to deal with, to provide different types of services. And this is where the notion of SDN really came about, because it tried to address this fundamental problem of how do I facilitate these type of different services that have requirements of different virtual networks on top of a common physical network. So if you really look at the evolution of a data center with SDN, you went from these vertically integrated boxes for certain types of services to more of a virtualized data center where you had all the compute resources virtualized in VMs, now going to more of a new SDN-based data center where the forwarding plane and the control planes are separated. You have these centralized controllers that have a global view of the underlying network, and they can really allow you to connect these different types of nodes in a much more virtualized fashion. So you are virtualizing essentially the underlying network as well. So this is kind of the story that has taken place on the compute side of the world. Now let's look at the network services side of the world. What I traditionally call the bump in the wire paradigm. These are all the types of platforms, whether in the enterprise space or in the public network space, where these are the platforms where a packet comes in, you do something to it, but then it goes out without being consumed necessarily in the platform. That happens in the compute part of the world, the compute services that I just talked about. Unfortunately, for the network services, these bump in the wire paradigm platforms, as you can see, I have pictorially tried to capture the disparate nature of these boxes by coloring them differently and giving them different shapes, although I may not have succeeded with the different shapes as much because you can only do so much. But all these boxes are not only physically separate, they have different architectures underneath. So when you are trying to take a lesson from the compute side of the world, where you had standardized platforms on which you could now instantiate these different services as virtual machines, becomes a lot harder in this paradigm. Same goes for a conventional wireless core network. You have all these different entities that make up the core network, but each one of them is separate. And the problem is that for an infrastructure, each one of these entities, whether in this paradigm or the previous paradigm, they have to be provisioned for the peak data rate that they are going to be subject to, but they may not always operate at the peak data rate. And if one entity is not operating at a peak data rate, you cannot repurpose its compute resources to do something different. So this is one of the problems that traditionally the network services platforms have faced. Now, from our perspective, we have tried to address this fundamental problem and trying to facilitate the move towards this network function virtualization paradigm by pursuing what we have called a 4-to-1 strategy. If you really look at all these network platforms, network services platform, there are fundamentally 4 different types of workloads that take place in these platforms. There is application processing, there is control plane processing, data plane or packet processing, and then in some specialized platforms like either wireless infrastructure, wireless access platforms, you have signal processing. Also, you have media processing type of platforms where they do a lot of signal processing. So you have these different types of workloads, and our goal has been to create the right kind of underlying architecture so that with one common instruction set and one common tool suite, you could actually provide these different types of workloads on top of that one common architecture. And that is the Intel architecture. I'm not really trying to put a commercial out there for x86 or Intel architecture, but I'm proud to say that we have actually made significant progress on proving that you could actually do application control and packet processing using Intel architecture at line rate. And by the way, when we started, most people didn't think that was possible. Same is being said right now for the signal processing, but we have some extraordinary partners like China Mobile and some of the other people in this audience that I don't want to name because that's not public information. But we are working to solve that signal processing, the final frontier, using the same architecture as well. So let's suppose that we solve that problem. And now you can actually provision these different types of workloads on one common architecture. Then we believe that we can lead this network transformation where from these proprietary platforms, you could get to one common architecture where now you can instantiate a control plane application or a data plane application or an application plane VM, all on top of one common architecture in a virtualized world, because we have virtualization enabled on this architecture. We are already in the 5th generation of virtualization. And then once we virtualize these network applications, then we can get to the same kind of SDN paradigm where you can create these virtual overlays of different types of network services running on this common infrastructure as well. So that is kind of the idea for us to move our architecture forward. And I must say that this didn't happen by just Intel focusing on solving these problems by itself. We worked with many of the folks in the audience to really understand what were the vulnerabilities of our architecture to deal with some of these workloads. And we had to eat the humble pie over the last several years when many of you told us that, hey, this really stinks as far as Intel architecture goes. And we took it constructively. We believe in constructive feedback. So we took it constructively and have evolved our architecture to be where it is today. So we just had this question about, so what is going to happen on the communications or network infrastructure side of things? So if we all recognize that the compute cloud is essentially moving to a place where there is going to be the public cloud, and some small and medium businesses may even have their entire private clouds sitting within those public clouds. They will create their virtual private clouds. But then many of the big corporations will still maintain their own private cloud. And again, they will have properties very similar to what we are talking typically as public cloud, but there will be more in their own control, and they will figure out some appropriate interfaces to the public cloud so that some of the services can be in the public cloud and some of the services are still retained within the private cloud. And same thing is going to happen on the network side, we believe, where the NFV, you can think of that as an infrastructure as a service of one type. It is, in a broad sense, it is essentially an IaaS as a cloud technology. And again, people will find the right kind of hooks into the public cloud for certain types of services, whereas many of the more value-added services may stay in the network function virtualization cloud or NFV cloud as a private cloud. And then the ultimate end state is what we call this software-defined infrastructure. That if you could do this, let's suppose, now you could instantiate either a compute service, which is what I call one of the sinks or source type of paradigms. You are consuming the packets and doing something and then providing a response in response to that packet. As well as network services, which are these bump in the road or bump in the wire type of paradigms. You could instantiate a compute service or a network service on the same underlying infrastructure, and now you have achieved the ultimate flexibility in terms of providing this software-defined infrastructure to enable these different usage models. Now, having said that, we do recognize that there are significant challenges ahead. There are differences between what was the compute cloud and this network cloud or the communications cloud. In the compute cloud, reliability is at the cloud level. They started with the paradigm that the underlying platform is going to fail. So they added reliability at a software, as a software layer at the cloud level. Whereas in the NFV side of things, reliability is, it starts at the node level. and it's a combination of hardware and software. So we need to think about how are we going to bring that same level of reliability if we were to take advantage of some of these technologies from the cloud side. On the cloud side, scale out is the primary focus. Every application, every service is developed with scale out in mind. Whereas on the NFV side, scale out is desired, but has not been proven yet. So we need to really study how these network services can use scale out as a fundamental architecture. Performance metrics vary across the SaaS and IaaS type of services. On the network side, performance per watt per dollar, which has been kind of the fundamental metric that we have used over the years, is still very much in play. Same thing with latency requirements. They have a lot more looser latency requirements compared to what the network functions have. And on the cloud side, they have really established this paradigm that you shall use standard high volume platforms. And all the innovation occurs on top of that fundamental platform using scale out. Whereas in the network space, the accelerators and more exotic platform features are still very much in play, and we need to figure out a transition of how do we move some of those fundamental things that we cannot get rid of into a more standard high volume server type platform, and then maybe leave the rest out and figure out how to solve some of those problems through scale out. Cloud is very much about cloud time. Things get developed, deployed, and provisioned in matter of weeks, or sometimes as long as months, but not like the 2 to 3 years time frame that we have seen typically on the network side. So we need to somehow figure out how to adapt to this cloud time. And then one thing that still is a big difference between the cloud and the NFV side is that NFV, or the network infrastructure, is still very much regulated. And license spectrum remains a key asset for most of the folks, most of the operators. So that's why I say that it's not going to turn into a public entity anytime soon. It will remain a private IaaS type of capability. So let me briefly talk about Intel's objective as we participate in various SDN industry forums. Now, I must say, while I am showing this picture of this 3-layer cake, as it has been known in the industry, of having different types of nodes, including the switches, controllers, and then orchestrator at the top, I have a hard time with this particular representation of how people are showing network applications or network nodes in this form, but then having these network applications kind of at the top as well. We need to do a better job representing the architecture that we need to work towards. But the main goal we have for SDN is that we want to evolve these different elements using standard interfaces. We want to make sure that whether it is southbound APIs from controllers to different nodes or controllers to the orchestrator, these things happen with standardized interfaces, because that is where we really leverage the entire industry and ecosystem. So we don't want to see proprietary things taking place in this evolution of SDN. And when I now use the term SDN and NFV, I'm talking about this converged notion of SDI and not just the cloud side of the SDN that I mentioned earlier. And then we have been kind of announcing some reference platforms. We just announced at ONS last month 2 platforms. There is a switch reference design that really tries to facilitate some of these innovations, and we also announced an open network platform server reference design which can act as one of these nodes. The one thing I would like to mention is that over the last decade or so, as we have worked with our industry partners, we really started understanding the workloads at the rack level, but then we built our platforms at the node level, the blade level. That is what we really focused our innovation on. As we move into this new space, we recognize that we need to start thinking at the data center level and then build our technologies at the rack level, because that is where the scale-out problem will manifest itself, and we really need to understand that, and we need help from our partners to make sure that we can actually understand the problems at rack level. So I very much welcome participation from everybody on that front, because yes, we will make sure that all the APIs are done right, and I'm not too worried about it. If we all put our mind to it, we can make sure that that will happen. However, there are some big challenges we have in front of us. Virtualization as a technology started out as a workload consolidation paradigm. It was not really designed to deal with real-time traffic. So how do we make sure that as we bring virtualization into this bump in the wire paradigm, the quality of service and, more importantly, quality of experience, SLAs, that the operators, Sarah mentioned that what is the fundamental value of an operator? I think she's right on the money when she said it is knowing your end consumer, what they want to do. So that quality of experience that an end user expects and demands is critical. And how do we make sure that we evolve the virtualization technology so that it can comply with some of those demands? The other big thing, if you recall, I mentioned that the way the compute cloud happened was because the first thing they did was they standardized the platforms and instrumented them. However, if you really look at the instrumentation that they did, it was a pretty rudimentary instrumentation. In the cloud space, typically there are 3 things you know, or you instrument. How many cores you have available, how much memory, and how much storage. That's pretty much the instrumentation that they started with. The kind of services we are talking about for network function, you need a lot more sophisticated platform instrumentation, so that then you can couple that with the policy or the orchestrator, which is going to manage policies, and you can create the right linkage so that as you are moving services around, you know that the underlying platform is actually capable to deliver on those services. So that is going to be another key issue. Reliability. This is one of those other things that in the comms industry, for last 13 years that I have been participating in that, long life reliability and the NEBS compliance and all these things are just nature of doing business. Now, when you are talking about leveraging the standard high volume platforms and using them with this scale out model so that you can actually hit some of these targets of lowering TCOs and all that, how are we going to deal with this reliability thing? Because if we put the same burden of the hardware having certain level of reliability of 10-year long life cycles, etc., it will become a lot harder to move to that kind of lower TCO paradigm. So we would like to have a dialogue with all of you in terms of, can we change that notion somehow so that we can still have a highly available network service, but do it in a fashion so that we could be more intelligent about it. Maybe we can have more predictive capability in the platform so that the platform can let you know before actually failing that, hey, I'm kind of getting some degradation in my platform capabilities, and you may want to think about replacing me within next 2 years. And many of the operators have those regularly scheduled maintenance cycles, and maybe if we have enabled a standard high volume platform to do some of these capabilities, then it may not be a bad cost equation to replace those platforms when you have next regularly scheduled maintenance cycle. So those are the kind of things we need to start talking about. I don't know exactly how it will evolve, but I do know that these are the questions we need to start asking. I already mentioned scale out for network services. We need to understand the workloads and really say, how do we make sure that these can take advantage of the underlying scale out? Isolation between multi-tenant domains. One of the things that, as I mentioned earlier, the operators are really trying to drive is that rather than being this black box or pipe on top of which other over-the-top carriers are getting, service providers are getting a lot of the value, how do they open up this pipe so that they can allow these service providers or content providers to take advantage of their pipe, but then in return they get paid for it. So how do we, in that case, you are going to have these multi-tenant domains going through your network in a much more intrusive fashion. How are you going to create the right kind of isolation between them? That is going to be another problem. And then, of course, the troubleshooting is, or diagnostics is always a big problem in a virtualized world. Because I always say that I showed that picture of the MME and S gateway and P gateway and all these boxes being separate, or in the enterprise you have firewalls and VPNs. Yes, it's a problem, but in a way, from a diagnostic standpoint, it's relatively easy because I can always stick an analyzer on a wire between the two boxes and figure out where the problem is. In a virtualized world, there are no wires. So how the heck actually you diagnose something? It is somebody's word against somebody else's word. That there is no. So these are the kind of things we need to start figuring out how we are going to do this in a virtualized world. So in summary, we believe that SDN and NFV are really about enabling this transformation of the infrastructure. We would like to evolve our architecture, Intel architecture, to facilitate this transformation. We are investing heavily in not just the silicon technology and the process technology. Several people have mentioned the Moore's Law, and it kind of, it is good to get that kind of confirmation of Moore's Law every time I go somewhere. But beyond the silicon, we are investing heavily in software and system level designs so that we can actually facilitate this new transformation. And as I said, we need industry collaboration. No entity by themselves in this room can pull this off by themselves. So we have to work as partners to identify and address some of these problems. And I think I really would like to thank the organizers for this event to really help us take that first step in that direction. With that, thank you very much. And if there are any questions, I'll be happy to entertain.
Questions or comments?
Mauri?
Thanks for a very good introduction into the area. So I agree that we need to look at this reliability and quality of service in a new way. I've heard from some operators already ideas that maybe this kind of 5 nines is not the right way to go anymore. Looking at the services, what kind of service are they running, and etc. And maybe things like not losing the context even if the connection drops and things like that might actually be more important. So I think that we need to at least take a look that that we best utilize these kind of new capabilities in here. Do you have any kind of question that do you have any view that how this migration from the current kind of network and box-like architecture would go into this direction? So.
Yeah, so we are looking at several technologies, and I won't go into a lot of details, but we really believe that we can build some sort of prediction capability or system-level analytics into our platforms so that you can monitor yourself. And it is interesting, when we started getting into this domain, I recognized how much similarity there is between hardware platforms and human beings. A transistor, as it ages, starts slowing down. And you can detect it and say, you know, at some point, if the platform can tell me that now that I am so many years old, I have recognized that I cannot run as fast as I used to, so I'm still useful, and I can still do the job if only you run me slightly slower. So there are those kind of things that we could do and say, I have a platform in place, I don't guarantee that it will run for 10 years at the same speed, but maybe after 5 years the platform says, I may be slowing down, you may want to run me at a slower speed for the next couple of years. And then there is a more, there is an opportunity for the operator to decide that, okay, do I want to do that? Maybe I'll do it for the next couple of years, but then in the next cycle, I'll replace the platform with a more efficient underlying architecture. So those are the kind of things we believe we can bring to the table. And then what we need to understand from your side is that, okay, if the hardware has this capability, how would you actually leverage that from a system software perspective? And then how do you tie that? You understand the operator's business a lot more than we do. So we need to collaborate on that front and say, how do we create the right kind of platform level solution to enable this paradigm?
Okay. Gillian?
Okay, maybe it's somewhat related to this discussion already, but anyway, first of all, great talk, and certainly many of us all know that Intel has been a close partner with us in our endeavor towards CRAN. And SDI, of course, is a much greater scope that encompasses the core network all the way to the edge. Mm-hmm. But specifically for the CRAN, we are focusing on making the base station or the RAN mm-hmm. software definable and reconfigurable. But I'm going to ask a very blunt question, because this is something I think internally we had some various discussion as well, because some doomsayers consider this move as an IT industry player invading the TEM industry territory. Mm-hmm. However, I believe both industry segments should kind of partner together to follow the technology trend and capability down the same road. It's just that I think we have a lot of TEM representative here. I would like to see a discussion as to how do you see a win-win partnership in this particular effort?
Yeah, so great question, and I have heard, we have had similar discussions in different forums. I think from my perspective, it's about meeting those three fundamental value propositions. I have to maintain my business integrity, but the market reality says that I don't get any more funding to invest in my infrastructure, so I need to lower my TCO. And given the new internet, and we heard about these micronationals and how new usages are evolving at a very, very rapid pace, so how do I make sure that I am building that kind of future-proofing in my platform and infrastructure so that I can respond quickly? So if those three things are the fundamental driving factors, I think it doesn't matter where the innovation comes from. It can come from the IT industry, the cloud, public cloud, private cloud, telco. We all need to be open to innovation happening anywhere and say, how do we embrace the innovation so that it can deliver to those basic premises? And as I said, as people talk about network function virtualization, I think there is tremendous hype in the market today. And I sometimes joke that the marketing engine is running way ahead of the development engine. And there are some serious challenges we need to solve before we can say this thing is actually going to happen. And that's where I'm sure that as we, for example, the cloud guys did not care for the latencies, right? The real-time response of virtualization. I can bet that if the telco side figures out how to bring that capability to virtualization, the cloud guys will embrace that because they will find new usage model for that. Same thing with the reliability. If the cloud guys can actually now have a better handle on the underlying reliability of their platforms, I think it will open up new things for them as well. So I think there is uniqueness on both sides, and the challenge is how do we create the right kind of environment so that innovation can flow both ways.
I think you're spot on, and you almost said exactly what I wanted to underline as well. I think we're far beyond the point whether you know, telecom versus IT or who will win. I mean, it's what we see now is two industries somehow merging, and both brings enormous capabilities and knowledge. And I think your presentation was a very good illustration about that to do virtualization in a network is different than in a data center. And I mean, if there is something we have to learn in the telecom industry, it's really this about cloud time. I mean, to that will bring the real benefits. I mean, it's of course there are some cost advantages as well, but I think the real thing is that you get a totally different time schedule when you get into virtualization, and that will benefit everybody. Not the least operators, who will then have a extremely shorter time to service.
And frankly speaking, even companies like Intel, we pride ourselves in terms of the pace of innovation, and Moore's law has established a cadence that we have to deliver to. But we are finding out that because of that, we had gotten into this pace of innovation that was measured in years. Moore's law is about doubling the number of transistors every roughly 2 years. So you kind of get into that mindset that, hey, we could create our roadmaps in this kind of yearly or 2-yearly fashion. And cloud time is not that forgiving. It happens at a much, much more rapid pace. So we need to somehow now figure out, it's not about the silicon anymore. It's the system. It's the overall solution. And how do you deliver innovation at this cloud pace, cloud speed? So that's what we are really trying to wrap our arms around. And I think that goes for everybody in here. So.
Okay, thanks. So I agree with your kind of reply basically to what Shinlin's question was, that, and in our company, so basically we moved to use Intel processors in the core part when others were still doing very much purpose-built silicon because we trusted on the Moore's law and being able to do clever software on top of it, and it has paid off. So we fully intend to move, and we are actually moving to virtualized infrastructure. But we are doing it the other way around. Maybe we start in the service core because that's the natural part, and come from there towards the radio. So in radio we are still pushing these guys hard to do the acceleration and stuff there, so that we can do that also. But it's clearly happening, and we are happy to work with these guys and do it all the time, and with some others also. Basically,
you always mention that, Lauri.
No, I don't mention that.
All of you always have this kind of added comment that gets. Trust me, we absolutely want to make sure that we remain intellectually honest, because in this industry, the moment you put your blinders on, that's the beginning of the fall. So we absolutely are on our toes and would love to understand where we lack and make up for it. So,
Okay.
thank you very much.
Pranav.